Mr. Math here. Today we're talking about expressions and evaluating expressions. This is a topic brought up in algebra. And basically a little bit of an intro to expressions. An expression is something that can be said. So for instance, if I said a number plus 8, this we would say is an expression. And in order to write that, I can use a variable, an operation, and a number, and I could say this is x plus 8. This is the number which we don't know plus 8. This is an expression. Generally, expressions do not have an equal sign, right? We're just kind of phrasing a certain number, like half a number, and then half a number would be, okay, take that number and divide it by 2. And this here would be our expression. Note, there isn't any equal sign brought in. Once we bring in an equal sign, now we're talking about equations. So generally when you're looking at expressions, you're looking at something without equal sign that has letters and numbers, and something that could be said or broken down into words. Now, you could be given expressions like such here, where we don't have an equal sign, and then you could be given values for those numbers. And in order to solve these or evaluate an expression, you're just simply plugging in. So let me take my a minus b plus c. You're just simply plugging in whatever you have for each variable. So in this case, and what I like to do is use parentheses, because it kind of represents that substitution that takes place, and it helps you with my signs. Because for instance, this is a minus b, and I'm putting in a minus 10. The mistake would be to lose one of those minus or negative signs, and then all of a sudden this looks like a minus 10. And I'll show you why in a second, because when you have the two negatives, that in turn is going to turn into a positive. If you did not add, you added, and then we get negative 3 plus 10. I'm sorry, this C actually, we should be plugging in a 1 here, right? This should be a 1, because we're plugging for the C. And remember, when we're dealing with order of operations here, if we have just addition and subtraction, we want to work left to right. If you're looking, the difference between negative 3 and 10 is 7. And in order to figure out what sign goes here, you find which has a greater number. Does a negative or the positive have more numbers? Here we have 10 positive. This is where there are more numbers. Therefore, this 7 is going to be a positive, because we have a difference of 7 positives here. And then, okay, we add the 1 at the end, and we end up with an 8. You could be given another example here where you have some addition and some multiplication. And again, I like to use the parentheses where I have the 3 times the 4 plus the 4 times the negative 2. Make sure we're going to be multiplying first. Now, see, the parentheses are helpful here because it kind of shows, oh yeah, that's my multiplication. Make sure I do that first. This could be written as a plus minus 8, or it could be written as a 12 minus 8 here, both of which, though, you have a positive 12. The difference between 12 and 8 is 4. What do you have more of? You have more positives, so we'll call that positive 4. Same thing here, our positive 4. Now, you could be given some expressions that deal a little bit more with order of operations. This is a question I like because it involves some fractions. Remember, in the beginning, we just want to get our substitution going right, meaning the 4 is going in for our y. I like to use, I maybe won't use parentheses in this case, but I definitely would on the bottom here, because I have a number next to that variable and I want to maintain that multiplication, minus 1 here. I'm using this 1 here because I don't want you guys to think it's an L or an I. And then the multiplication, you want to multiply first. There is multiplication division here, but it's best to work or multiply or divide anything that can be done in the numerator or denominator. You want to take care of first. 4 over 12 minus 1. Now, in order to subtract these two fractions, don't forget we have to make this into like denominators. So what I'll do is I'll make this 1 over 1. Now the 1 over 1, if I want to make a like denominator, I got to multiply the top and bottom by 12. And I get 12 over 12 here. So this essentially becomes 4 over 12 minus 12 over 12. Again, actually I haven't said this yet, but the denominators we're not going to add or subtract. It's just the top numbers going to work with, because we're saying we have 4 of these 12s and we have 12 of these 12s. So how much do we have all together? Well, in this case, look, now we have 4 positives and 12 negatives. What's the difference between these two numbers? The difference is 8. What do I have more of? I have more negatives. So this in turn will become a negative 8 over 12. Now you may have to take this negative 8 over 12 and reduce by the biggest number. Now 2 does go into 8 and 12, but so does 4. And this is my biggest number, so that's the one I want to work with. And in this case, I'll get a negative 2 over 3. And this is how I would evaluate this expression using order of operations. This is a good one too, because we talk about kind of evaluating and working out some of your operators in the numerator and the denominator here. Actually, I want to put this in order. This should actually be an A here, and then we'll call this a B, right? That's our A and B. And we have an 8 times a 4. 8 plus a4. Again, I'm using the parentheses to keep my multiplication where I want it to be. 8 times 4, 32, 12. And again, here's a number in which the top and bottom, numerator and denominator, are an even number. I can divide by 2. I can divide by 4, but I will use the bigger number 4 here, and I'll get 8 over 3. Now, if I did reduce by 2, which would have given me 32 divided by 2 is 16. 12 divided by 2 is 6. You see, I end up with 2 even numbers again, and I in turn would have to divide by 2 again to continue to reduce, and there I would end up with my 8 over 3. Just remember a little bit of review. The expression is just something that could be written and put into numbers. That's something you just want to kind of remember about expressions. And remember, you always want to put in the hard work and practice. Hard work is what makes math easy.